Chapter 5, Association between Categorical Variables. So far we have learned about the different variable types, categorical, numerical, how to do summary statistics. Now let's find out, when we take two categorical variables, how do we see if there is any association? What is the way to measure that? Take a real life example. If you were to book a flight and you're trying to decide, should I take American or Southwest? Which one should I take to maximize that I reach on time? Two variables, flight taken, reaching on time. And you want them to be associated. You want to make sure that your decision number one is associated with likelihood of maximizing that you reach on time. So when you look at your data, you want to find out which one there is a higher association, higher likelihood that if I take this flight that I will actually reach on time. Another example, let's say you're trying to grow your online business and you want to place ads. Should you place ads on Google AdSense or like Facebook ads? Where should you place your ads so that you can maximize the purchase or maximize the visits, and you maximize the visitors becoming, let's say, a loyal member of your website? Ads placement, or the dollar spent, and visits is the two variables. Maximizing those two so that I get good quality candidates or good quality people coming into my website. So you want to find out which is a better source. Another example, let's say you're Amazon. I like taking Amazon throughout these videos, and you're trying to find out, hey, should I keep a blue t-shirt for medium more in my inventory, or should I keep a blue t-shirts less for my smaller inventory? So size and popularity. I want to find out which one should I stock more, which one's more famous, that I will maximize the profit or maximize the sales. Now these are all variables that are associated, and how do you make sure that you pick the right ones? And these are all categorical variables. Contingency table is one way in which you can, let's say in this case, the ads example, you can place the ads on Google, Facebook, or some other website, and you get, another variable, which is the purchase on the Y. You say yes and no, and then you break it down. Look at the data and break it down. And you can quickly find out, hey, Google is actually sending me less number of good quality versus Facebook. And then when you do that, you can actually create a plot like this called the Mosaic Plot, where you plot the Google, Facebook, and others. And you can see like, hey, which one's more associated. And when you do that, it's very easy for you to find out like which decision is going to be much more helpful. The distribution on the margins is called the marginal distribution. So you can say, hey, this 80 out of a total of 300. So Google overall is a small share in this example. And a conditional distribution is, if you just look at Google and if you look at all purchases for Google, then it is the conditional on these two different variables. If the conditional variable and the marginal variable are different in terms of percentages, or the percentage is different in terms of distribution, then you know that there is some sort of an association. If they are the same, then there's like hardly any association, right? But if they're different, then there's some association. But association does not mean causation. That's the key thing to keep in mind. Because you just looked at these two variables. There could be a third variable that's much more impacting the causation beyond all of this. So keep in mind that association is not equals causation. Association is a prerequisite in some sense that could lead to more discovery towards an eventual causation. So we looked at contingency table. We looked at how two variables, ads placement and purchase, flights being on time, inventory and sales. How do we find out if there is some association? Now we also want to find out the strength of that association. Right? We just don't want to know like, hey, this is higher, this is lower, but like, what is the strength? So we have this test called the chi-square test. You remember in the previous video, we did this thing called standard deviation, where in the given data point is subtracted by the mean, and we calculate the square of that, divide by the total number of sample space, we get variance, and then we square root of that, we get standard deviation. Similarly, very similar but not exactly the same, we have chi-squared test and Kramer-Sweet. Chi-squared test is basically for every data point, subtract that with assume that there is no association. So example, if there's 80 data points coming from Google, you just put 40, 40 here. And then that becomes your y1 bar, y2 bar. So when you subtract your observation minus as if there was no association, square that by, divide by no association, you get chi-squared. It's basically, it's higher the chi-squared, higher the association. Lower the chi-squared, lower the association. So chi-squared, and if you divide chi-squared by number of data points and a minimum of the row -1, column -1, then you get Kramer-Sweet. Kramer-Sweet is actually a better way to find out strength of association. Chi-squared is also a good one, but it varies quite a bit. Kramer-Sweet brings that whole thing down and reduces the bias, and then you get a number between 0 and 1. And 0 is like no association, 1 is like perfect association. Anything above 0.5 or 0.7, 0.5 moderate, 0.75 and above is high association. So Kramer-Sweet is a good one to find out the strength because it removes the bias of the sample size. And we looked at like two different plots, right? Mosaic plots and stacked percentage bar charts, which gives you a very clear understanding of like for a given condition, which variable is better. And you can also find out the strength. If you, let's say, in Kramer-Sweet, actually you can compare two different things. Like let's say here you're comparing the strength of this association for, let's say, flight versus strength of association of inventory. Then you can actually compare, hey, this is a higher strength than this one, right? Just in its own data space. The last part is, I told you that, hey, this will work if these data points are mutually exclusive and there are no lurking variables. What's a lurking variable? A variable that can change this whole understanding of the data, because that's actually closer to the causation. Let's take an example. Here, if I were to tell you that, hey, although Facebook sends you more, but actually if the loyal visitors coming from Google, even though they come less, is much, much higher than Facebook and others combined, then you'll be like, hey, I shouldn't be spending as much even though I get a lot of volume. So Kramer's association, chi-square is good, only works if there is no lurking variables. If there are no confounding variables, the third variable that's actually affecting this. So you've looked at these two variables, ad placement and purchase, but there could be the third one, which is conversion or loyal conversion. You could find out that, hey, Facebook maybe sucks in that, and then so you probably want to go down with Google route. Similarly, even for flight on time, let's say you decide between Southwest and American, and you say, hey, American's much better because overall in the aggregate, it's fine. But then when you break it down by destination, then you realize that, hey, the destination that you're trying to go to is the destination that Americans worst at. So you don't want to take that, right? So it may very well be biased on like the most frequent path that it's going. So the overall it looks good, but only when you understand the domain really well that you can break it down into what makes sense, much more closer to the reality. Then you go from clear association to slightly closer towards causation. And so keep this in mind. These needs to be mutually exclusive, and there should be no lurking variables that actually you're missing out because you don't understand the domain as much. And be very, very cautious to jump to conclusion that, hey, this association means it's causation. No, there are many things going on, so constantly improve on understanding the domain better and break down this data points into much better logical sense. And that will help us to understand the strength of this association between categorical variables. We can actually find out, hey, which flight you should be taking, which inventory you should be stacking, which stock you should be buying and which stock you should not be buying. Thanks. In the next one, we will see association between numeric or quantitative variables. We looked at the categorical variables. Thank you.